Hello everyone, my name is Garv Thakkar and you are watching a presentation based on Introduction to Blockchain. Here, you will learn about blockchain and all the basic terminology related to it. This presentation is brought to you by RazzorSec. RazzorSec is a company which is dedicated towards the security and infosec side of blockchain. So let's get started with the presentation. This presentation or session is divided into three parts. The first part covers the jumpstart topics, which are required to understand the concepts of blockchain. The second part covers introduction to blockchain itself and all the basic terminology. The third part covers more in-depth topics related to blockchain. So here comes the first part. So the jumpstart topics that we are going to cover are peer-to-peer networks, cryptography, centralization, decentralization, and difference between centralization and decentralization. So let's get started with the first topic, that is centralization. So centralization or say centralized networks. What are they basically? A type of network where all users connect to a central server, which is the acting agent for all communications. This server would store both the communications and the user account information. Most public instant messaging platforms use a centralized network, also called centralized server structure. In simple words, if clients wanted to connect each other, they would be able to do that through a central server or a data center, which means if one person wanted to share files or information with the other, they would have to upload it on the server first. From there, the second person would download it and then would be able to access it. This means the person who is in control of the servers will be able to see everything going in and out of the server and would be able to access the data himself too. Which means by trusting centralized systems, we are putting our data and our privacy at risks. And this also adds the disadvantage of single point of failure, which means if the server crashed, it would destabilize the whole centralized structure. Or let's say the server gets hacked, then the hacker would have all the information of the users on his fingertips. Now, let's move on to our second topic, which is decentralization or say decentralized networks. What does decentralized mean? As the name suggests, it's quite the opposite of centralized. Decentralized networks are organized in a much more distributed fashion. Each node within the network functions as a separate authority with independent decision-making power regarding how it interacts with other systems. These networks also distribute processing power and workload functions among connected servers. In simple words, there is no primary server or a data center. Clients connect to each other directly without routing the traffic through a main server or a data center, hence distributing the workload and making things more private and secure. So now let's move on to our third topic, which is peer-to-peer networks. In a P2P network, the peers are computer systems which are connected to each other via the internet. Files can be shared directly between systems on the network without the need of a central server. In other words, each computer on a P2P network becomes a file server as well as a client. In simple words, it basically follows the decentralized networking. If you didn't understand what that is, you can rewind back to the previous slide or pause the presentation here to read the slide. So, now that we have discussed centralized and decentralized networking, you may ask, what's the difference between them? Let's discuss. The word centralized gives away how the networks are structured. A centralized network has a middleman to facilitate its operations, like a bank of all your transactions and information. This means it holds all your data and therefore trust is paramount. And a decentralized network is a trustless environment where there is no single point of failure. The nodes connected in the network are not dependent on a single server point, and each node holds the entire copy of the network configurations. As the information never passes through a single server, a decentralized network is highly secure. Let's watch a short video which shows how clients connect to each other in a centralized and a decentralized network. I won't disturb you guys much and I'll let you watch the video. Now, we have come on to the last topic of part 1, which is cryptography. Cryptography is a method of protecting information and communications through the use of codes so that only those for whom the information is intended can read and process it. The prefix crypt means hidden or vault, and the suffix graphy stands for writing. In computer science, cryptography refers to secure information and communication techniques derived from mathematical concepts and a set of rule-based calculations called algorithms to transform messages in ways that are hard to decipher. These deterministic algorithms are used for cryptographic key generation, digital signing, verification to protect data privacy, web browsing on the internet, and confidential communications such as credit card transactions and emails. In simple words, it is a method to encrypt and secure the information that is supposed to be transferred so that only sender and receiver can only read or write or modify it. Now, let's recap all the topics we looked at in this part. Number 1. Centralization. When clients connect to each other through a server or a data center and all the network traffic is routed through it, which forms a centralized and partially insecure network, we call it centralization. Topic number 2. Decentralization. When clients connect to each other directly and form a distributed and secure network, we call it decentralization. Topic number 3. Peer-to-peer networks. Peers, nodes, or blocks are computer systems that exchange information, data, and conduct transactions on the decentralized network. Topic number 4. Cryptography. It is a method to encrypt and secure the information that is supposed to be transferred so that only sender and receiver can only read or write or modify it. I hope you guys had a lovely part 1 and I hope you guys learned something. If not, feel free to ask questions in the comment section, and if not, try rewatching the video. Thank you.
What is blockchain? A blockchain is a growing list of records called blocks that are linked using cryptography. Each block contains a cryptographic hash of the previous block, a timestamp, and transaction data. By design, a blockchain is resistant to modification of the data. It is an open distributed ledger that can record transactions between two parties efficiently and in a verifiable and permanent way. Note that various keywords used in this slide will be discussed later on in this course. Structure of a blockchain. A blockchain is a decentralized, distributed, and oftentimes public data ledger consisting of records called blocks that are used to record transactions across many computers so that any involved block cannot be altered without the alteration of all subsequent blocks. This allows the participants to verify and audit the transactions independently and relatively inexpensively. A blockchain database is managed autonomously using a peer-to-peer network and a distributed timestamping server. They are authenticated by mass collaboration powered by collective self-interests. Such a design facilitates robust workflow where participants' uncertainty regarding data security is marginal. It confirms that each unit of value was transferred only once, solving the long-standing problem of double spending. A blockchain has been described as a value exchange protocol. Now, why do we use the word oftentimes here? We use this word because there are different types of blockchains other than a public blockchain, such as hybrid and federated blockchains. Bitcoin and Ethereum is an example of a public blockchain. A blockchain database or network is similar to Tor network. Both of them are peer-to-peer connected and decentralized. Again, this removes the chances of failures, hacks, crashes, etc. Many times, a blockchain node is managed by various participants or different people together, which brings down the expense used in hosting a blockchain node. They are mostly hosted for self-interest like earning cryptocurrencies, etc. This structure of blockchain thus eliminates the chances of double spending. In other words, would trying to send an amount in more than one place together. Hashing. In simple terms, hashing means taking an input string of any length and giving out an output of a fixed length. In the context of cryptocurrency like Bitcoin, the transactions are taken as input and run through a hashing algorithm. Bitcoin uses SHA-256, which gives an output of a fixed length. Blocks. Blocks hold batches of valid transactions that are hashed and encoded into a Merkle tree. Each block includes the cryptographic hash of the prior block in the blockchain, linking the two blocks. This process confirms the integrity of the previous block all the way back to the original Genesis block. Sometimes, separate blocks can be produced concurrently, creating a temporary fork. Named after Ralph Merkle, who patented the concept in 1979, a Merkle tree, also known as the binary hash tree, is a data structure used for efficiently summarizing and verifying the integrity of large sets of data. Hashing functions are mathematical algorithms that take inputs and provide unique outputs. Some of the most common hashing functions are MD5, SHA-3, SHA-256, the last of which is used by Bitcoin. These hashing functions will produce unique values that you can later use to represent the inputs. Genesis block is the name of the first block of Bitcoin ever mined. The Genesis block forms the foundation of the entire Bitcoin trading system and is the prototype for all other blocks in the blockchain. In 2009, Bitcoin's named developer Satoshi Nakamoto created the Genesis block, which launched the process of Bitcoin trading that's in place today. When several miners discover one block at the same time, a temporary fork occurs. The result of such performance is a split between a blockchain network. Orphan blocks in blockchain. Blocks not selected for inclusion in the chain are called orphan blocks. An orphan block is a block that has been solved within the block network but was not accepted due to a lag within the network itself. There is no reward for solving a block, which is then determined to be an orphan block. The first miner who is successful in finding a new block is entitled to the block reward and writes the first transaction on the new block they have found. In order for the blockchain network to continue function, the newly found block gets added as a new unit on the blockchain. It is possible that two miners produce a block at a similar time. This time lag is accepting a block may lead to another miner solving for the same exact block. It leads to the temporary mix-up on the blockchain network as the nodes try to decide which block of the two newly identified blocks it wants to accept. In such a situation, the block with the largest share of proof of work gets accepted in the blockchain. The other block with a smaller proof of work is discarded from getting added to the blockchain and is termed as an orphan block. Such blocks are essentially valid and verified blocks, but due to the network's working mechanism and the lag time leading to delayed acceptance, one of the blocks is rejected or orphaned. A proof of work is a piece of data which was very difficult to produce as it is a very time-consuming process. This is mainly created to satisfy certain requirements. This process always goes through a verification process to know whether the satisfying data requirements are up to mark. Nodes. Nodes are copies of ledgers which people rely on to keep track of cryptocurrency transactions that have occurred on the blockchain. Anyone who wishes to can create a node and will have their own copy of the full blockchain transaction history for any specific cryptocurrency or for a number of different cryptocurrencies. However, nodes take a lot of memory to run because blockchains can contain an extensive amount of data. For this reason, anyone who wants to create nodes has to be prepared to handle all of this data smoothly. So, what does this mean? As we know that blockchain is a decentralized infrastructure and there is no central governing authority, nodes act as a storage device or a server that stores a full ledger of transactions happened till date in a blockchain network. Every node holds a complete ledger of a cryptocurrency blockchain independent of any other node. As there are a lot of transactions happened on a blockchain network till date, one needs to have a lot of storage space available in order to store this ledger smoothly. Purpose of nodes in a blockchain. The purpose of nodes is to preserve the integrity of the blockchain for a particular cryptocurrency, and the entire blockchain history can be preserved even if there is just one node running it anywhere in the world. This makes cryptocurrencies that run blockchains extremely resilient to things like hacks, power failures, or systemic crashes. Despite the fact that it only takes one node to preserve a blockchain transaction history, blockchain-based cryptocurrencies typically have hundreds, thousands, or even tens of thousands of nodes running at any given time. The more nodes that there are for a cryptocurrency, the safer that cryptocurrency is. Now, what does that mean? This means that even if there is one node left in the blockchain network, still its history can be preserved, as we know that a node stores a full ledger, also known as transaction history, on it. This removes the possibility of hacks, data tampering, and system failures as it is not stored on a central server. A typical blockchain has thousands of nodes running at any given time. Mining is not about creating new bitcoins. Mining is a mechanism that allows the blockchain to provide decentralized security. It secures the Bitcoin system and enables a system without a central authority. Miners validate new transactions and record them on the global ledger. On an average, a block is mined in every 10 minutes. Miners compete to solve a difficult mathematical problem based on a cryptographic hash algorithm. Miners receive a reward when they solve the complex mathematical problem. There are two types of rewards: new bitcoins on transaction fees. The amount of bitcoins created decreases every 4 years. Miners can also receive rewards in the form of transaction fees. The winning miner can keep the change on the block's transactions. As the amount of bitcoin created with each block diminishes, the transactions fees received by the miner will increase. Now you would be wondering, what is the difference between a node and a miner? Miners validate transactions in a blockchain. We often hear about Bitcoin mining. Miners are the workers in a blockchain that tries to keep the proper functioning of a blockchain, whereas nodes store all the transaction history of a cryptocurrency blockchain. They are distributed standalone servers. Let us look at the examples how blockchain can be beneficial for various industries. Finance. The financial industry can use blockchain to redesign costly workflows, improve liquidity, and free up capital. The technology can also help reduce infrastructure costs, increase transparency, reduce fraud, and improve execution and settlement times. Healthcare. Blockchain could allow people to always have access to their healthcare records and grant people access or revoke a person's access from their health records and have that data always stored, encrypted, and protected on a blockchain network. Government. Blockchain could increase the transparency and traceability of how money is spent in the government. It could also track asset registration such as vehicles and reduce fraud and operation